Right, final question. An electron is accelerated in the uniform field E with that strength between two thin parallel charged plates. That is why it's considered uniform. Although you'll notice they at the edges, the uniformity breaks down a bit. The separation of the plates is given. The electron is accelerated from rest near the negative plate and passes through a tiny hole in the positive plate. Okay. So with what speed does it leave the hole? Right, so it's an electron in a uniform electric field, so everywhere the electric field is the same. So remember what we have from a electric field. By its definition, the force is equal to the charge of the particle or whatever times the electric field. This is directly from the definition of an electric field. So if electric field is uniform, then that means the force is uniform. It's constant. Electric field is uniform means it's constant. So then the force is constant. If the force is constant, then that means constant acceleration. And the force is everywhere the same along the trajectory. Okay, so we know the force everywhere along its path. You know, from year to year we know its force, and it's because it's the same everywhere. So this is in fact a very simple mechanics problem, similar to the ones you would have seen in first semester. Okay, so there's two ways to solve this. Right. Now the simplest way, okay, so it's the first is part A. Let's do part A. Okay. So the simplest way is just to think in terms of kinetic energy. So going from the negative plate to the little hole, there's going to be a change in kinetic energy. The change in kinetic energy is going to be the net work done the net work done on it. In this case, by the electric field. Okay. So the change in kinetic energy, that is half mv squared minus half mu squared, where v is the initial velocity and u is the v is the ending velocity and u is the initial velocity. Okay, and what is the work done on it by the electric field? That's going to be the force on it along the direction that it's moving. Okay, so it's moving from year to year a distance d, and everywhere from year to year along a distance d, it's going to experience a force. In which direction is the force? Okay, so well, it should be in this direction because it's accelerating in this direction, but just in terms of how we understand it, let's just check that our understanding is correct. The electric field is in this direction, which is the direction a positive charge would feel a force in, but this is an electron, it's a negative charge, so it will experience a force in the other direction. Okay, so this is in agreement with what we understand. Okay, so it will experience a force directly in this direction, directly in the direction that it's moving. So the work done on it will be the magnitude of that force F times the distance over which it works in, which is d. Okay, well I say d, so where d is well, I'll substitute it. Is equal to the 1.6 centimeters, 1.60 centimeters. Okay, right. Okay, so this term falls away because it states that the electron, it's stated here, the electron is accelerated from rest. Okay, so it starts at 0. So this is just a half mv squared is equal to F. And what is the force? Now, from definition of electric field, we have this, which means that the force magnitude is the absolute value of Q times magnitude of E, as we discussed in class. Okay, so this is the absolute value of Q times E d. Okay, and what is it that I'm interested in? I'm interested in the final velocity that it exits the hole with, so that is v equal to, okay, now this is just a matter of getting v by itself. Okay, so this is going to be 2qed over m. Now the question doesn't specify m actually. let's see, where have I written that down anywhere? Okay, no, well, normally a question will provide this, otherwise you can just look it up and it's in front of your textbook. It should be what the test or exam it will be provided. So that is the mass of an electron, and you know the charge. Charge is minus 1.6, or if you want to put extra significant figures, times 10 to the minus 19 coulombs, right? Or you could just have written 1.6, but again, this is a question which the values given, the electric field strength and the distance between the plates are both given to 3 significant figures, so I'd rather use more than 3 than less than 3 significant figures, so I'll opt for this one instead of just 1.6 times 10 to the minus 19. Okay, good. Now let's just substitute the values. So this is 2 times, and this is absolute value of that, so that's just 1.602 times 10 to the minus 19 coulombs, times electric field strength. This is given as 1.45 times 10 to the 4 newtons per coulomb, times the distance, which is 1.60 centimeters, so 0.0160 meters. Okay, over the mass, 9.11 times 10 to the minus 31 kilograms. Okay, so now I've got to calculate this entire thing. Okay, let's see here where we can see it nicely. Okay, so this is 2 times 1.602 times 1.45 times 0.016 equal divided by 9.11. Okay, times 10 to the what? Minus 19 plus 4 plus 31. Okay. Okay, so that is what is inside the square root, and then I just take the square root of this. Oh, geez. Okay, how do I get the answer again? Where's the answer? I'm looking over it now. Answer, where are you? How am I missing it? I don't really want to redo the video because I can't find answer. Is it normal? Right. Yes. Does it not have that functionality? It should. Where is it? Probably right under my nose. Oh, I'm thinking of MATLAB. Ah, that's what I'm thinking of. There you have that. Huh? Or am I? Oh, no, now it's... No, that's wrong. Let me see now what it... okay. Okay, 2 times 1.602 times 1.45 times 0.016 divided by 9.11. Okay, times 10 to the power minus 19 plus 4 plus 31. Okay, takes that to the power 0.5, and that is the answer. Okay. This is a final answer, by the way, so I'm going to provide as many significant figures. That's the minimum number provided by the question, and that's going to be 9.03 times 10 to the how much? 246 10 to the 6 meters per second. Okay, that's it. Or there's another way of doing it. The other way would be using those equations of motion that you derived or wrote down, and you used a lot in high school probably. That is, you just need the acceleration. If you've got the acceleration, you know the initial velocity is 0. You know the distance. So there's just a simple equation you can use. So we just need the acceleration. So F is equal to the mass times the acceleration magnitude. So A is equal to F over m, but F is Q E over m. So that's the value for the acceleration. And now you remember there is one of the equations of motion is this one, v is equal to u squared plus 2a, well I use d in this case, for the distance between the plates. Okay, that is just 0. And what am I am after v, okay, so v is equal to the square root of 2AD is equal to the square root of 2Q QED QED 2QED over M. Okay, and that you can calculate as well. So just substitute all the values for that. 2 times 1.602 times 10 to the minus 19 coulombs times electric field strength 1.45 times 10 to the 4 newtons per coulomb times distance 0.0160 meters over the mass 9.11 times 10 to the minus 31 kilograms. And let's calculate that. Should be, oh, we don't actually have to. You'll notice it's exactly the same, exactly the same calculation. So this is equal to also 9.03 times 10 to the 6 meters per second. Now, as for B, to show that the gravitational force can be ignored, well, gravitational force causes a certain acceleration. Gravitational force be ignored. Well, that is presumably because this is taking place on Earth. So in that case, we're going to use the G 9.80 meters per second squared, which is the acceleration due to gravity close to the surface. So that to show that that is negligible, I'll compare it to this acceleration. So let's just to explain carefully what I'm doing. Let A be electron, well, the electron's acceleration due to E, and we know G, what G is. Let's just use so much I don't really have to explain it. So let's just calculate A over G. So we got A from that one, so this is equal to Q E over M G. So let's substitute all of that and calculate it. 1.602 times 10 to the minus 19 times 1.45 times 10 to the 4 newtons per coulomb over 9.11 times 10 to the minus 31 kilograms times 9.80 meters per second squared. And let's calculate that just to see how the acceleration caused by the field compares with G. So okay, so that is 1.602, this is 1.45 divided by 9.11 times 9.8. Okay, and times 10 to the power minus 19 plus 4 plus 31 again. Sure. So that's quite hectic. Yeah. That's the exact value. It doesn't actually matter here. It doesn't matter. Let's just say it's approximately. Not do that. This message. It's approximately 2. Actually, we're just interested in the order. It's approximately 3 times 10 to the 14. So that acceleration due to gravity divides into the acceleration due to the electric field this obscene number of times, which just directly goes to show thus acceleration. Well, okay, I don't have space to write it down. So you would then say, because thus the acceleration due to gravity is negligible due to acceleration due to the electric field. So gravitational force can be safely ignored. That would be your answer. Okay, and that's it for the final question.